And what's up, guys? So let's solve this 1, 2, 2, 0 count vowels permutation. So give an integer, and your task is to count how many strings or lengths and can be formulated under the following rules. Okay, so A, I, O, U, and let me just write down. So the A may only be followed by E. So what it means that A can only by follow E, and the E can only by A and I, and the I it cannot be followed by I. So A, E, O, U. And how about O? O is I, and U, and U can only A. Okay. And the answer may be too large. Return 10 to the 9 plus 7. Okay, so this problem is not hard. This problem is just some boring dynamic programming. Okay, so N is 1, you get 5, right? ALU. N is 2, you get AE, right? So A must follow from E, EA, right? Sorry, I'm stupid. Okay, so right, so you can check for N equal to 2, right? A can only E, right? E can only A, but E can only I, E can also I, and I can only A, I can only E, I can only U, O, I can only U, L can I, O can U, U can A, right? So how many of them, right? 10 of them. Okay. Okay, and hopefully you guys already see a trick. Okay, so let me just quickly solve it. So what should we do, right? So let's denote the dp0 n to be the something with length n for rule but ends in a. Okay, so there are something. Okay, and the dp1n to be and the one e, and the dp2n will be up from I. dp3n will be up to U, right? Sorry, O. And the dp4n will be ends from U. Okay, and we need to find a recursion. Okay. Hope you guys can see. Okay, so let's find a relation. Let's say for each guy. Let's maybe do this. Okay. So now since we A, right? So I want to ask that who can be which one can be here, right? Which one can be here? Okay, so let's say if we ends A, right? Who can ends A? Right. So E can ends A, I can ends A, U can ends A. Let me just write this E, I, U, and who can ends E? A can ends E, right? And A can ends E, and I can ends E. Okay, there's no way, no other choice. A, E, I. So who can ends I? Who can ends I? E can ends I, and O can ends I. And A, E, I, O. Who can ends O? I can ends O. No other can ends O, right? U, who can ends U? O can ends U. I can end U. Okay. So this tell you what? This tell you that your dp0 n can be written as a dp, right? E is 1, right? So dp1 minus 1 plus dp2 minus 1 plus dp4 minus 1. This is E, this is I, this is U. Okay, so this one. And what about dp1n? So dp1n is E, right? So E can be written dp0 minus 1 comes from A, and the dpi comes from AEI. So I use 2 minus 1. Okay. dp, how about the I? dp2n can be written as dp0. E is 1 plus dp O. So dpo is 3 minus 1. Okay, and the dp3n, which is O, O can only come from I. So dp3n is dp2 minus 1. Okay, finally is this line, right? So I and O. So DP for N, it's DP I is 2, right? So 2 and minus 1 plus O, 3 and minus 1. Okay, so this is all the transition equation 1, 2, 3, 4, 5. And what is your trivial boundary condition? So your boundary condition is that dp 0, 1, dp 0, 1, 1. Suppose you only have one numbers, so 1, 1, right? Okay, so you start from here and use this transition equation to compute everything. Okay. Oh, don't worry. Okay, so dp 0n, right? So dp oh my god. I use 0, 1, 2, 3, 4, 5 to at the first indices, right? But it's the same DPI 0, I minus 1, 1, 2, 4. You see 1, 2, 4. For this one, it's 0 and 2, 0 and 2, 1 and 3, 1 and 3, 2, 1 and 2 and 3, right? So it's actually just reverse transposes. So DP originally is set in from 0 times 5 for average and plus 1, choose M, and so M is very large, right? So hopefully when you do the computation, you should modulo M at every positions. And finally, you just take everything, right? Because your final end results can be AIOU. So you add the results and final results I think this is very important for each step that you should always MAN, right? Because MAN is very large, so you should do every step. See you guys next videos. Hope you guys subscribe to my channel.